Thanks once again, DPDK community, for allowing us to talk on the second day with regard to Meson or the migration to Meson. Today, as usual, I'm accompanied with Shiva. We both work with Intel and we help people to get acquainted with DPDK and get the best out of the system. Now, just a small primer about Meson. Shiva? Yeah. We got a notice in the DPDK mailing list saying that a warning saying from 2005 release, there is a warning stating that Makefile would not be in future it would not be supported. And if in 2008, if we try to run with Make, we get a abort and all. And the upcoming 2011 release, it is complete. The Make infrastructure is completely removed out. Now, as we understand today, and when customers ask us why Meson, why Make has been removed out, the simple answer is that it has less number of bugs when it is running in parallel, and it is much more easier to configure use because it is much more similar to Python like format, and it builds faster at the end of the day. So anything that runs faster and easy to use and is simple in nature is the best thing. So we agreed. Now, trying to share what we want to have or from our agenda point of view. If you look at it, basically we want to emphasize on three major sections. First one talks about the current scenario or current setup, what the customer has, how they do it today, and what all things they look out or do extra configuration to get it similar to their requirements. Then we try to see what does DPDK and the community and the documentation has to say about Meson and how we can achieve it. And if there are any missing gaps in it, how can we add without manually editing or without going and fidgeting around the RT config or other things, how we can make it work as simple as possible. That is what we are targeting for today. Okay, so as we see, basically, most of the end user customer has deployments, continuous integrations and all, which builds making use of the Yocto, Bitbake or CMake at the end of the day, which generates necessary configurations and enough arguments, which is fed to the Makefile to build DPDK library and PMD. From that DPDK library and PMD, the third-party libraries, the frameworks, and even the end application which makes use of DPDK are built, which is then getting deployed over number of distros on Linux and even the custom build Linux and all, which is then running in a VM and Docker. Our talk mainly focuses on Linux because most of the customers that we interacted are making use of Linux as of today, and we are sharing from that perspective. So as we understand, there are basically three types of configuration that is dealt in. Number one, the basic setup and configuration that is associated as a default parameters of our current DPDK release. Then user specific configuration, which enables and disables certain parameters, certain libraries and PMDs. And end of the day, the target configuration, which is necessary to cross build it. These settings gets ported or gets added into the third-party libraries and the end applications too. Next slide, please. Yeah, so just to give a small reference point, in a cross-build scenario, these are some of the target files, these are some of the export variables we normally export, then we use the things and all. Next. So with the right environment configuration, we can build DPDK just by exporting the necessary RTE configuration and get the PMD and library. Along with that, the end user can also get natively or cross-build the sample application what they want to use on the target system and get it done. But this is just the library and all. There are lot of more customization. Next slide, Shiva. So, for example, if you have a VM or a Docker where you are not emphasizing at all on the physical NICs, and we can disable all the physical NIC from getting built. if I want to have a debug version of the DPDK library, I want to enable malloc debug in the .config file. What is available from the make system, I can go there and enable the malloc debug. Similarly, I can enable disable hashing. I can enable the PTP stamping. I can tell whether it is going to be built with shared library or static library and all. These are the kind of flexibility I get at the end of the day when customers were using make and .config. So also there were custom libraries and custom binary PMDs which were added to the vanilla DPDK to support new features and new things. So what they used to do, they go to the folder, they add the files, they put in a make file, and everything done. They go and edit the RT config and make it work. They just fire make, it gets built, and these were the kind of things what they were comfortable on. Next. So what we got to see from the customer point of view, I have a build machine. This build machine has multiple folder. For example, I have a build folder for Xeon. I have a build for Atom. I have the simply customized build binary and libraries. I have the debug enabled with extra C flags and other .config extra debug things are I have built it. I have one image that runs on the bare metal. I have another image which runs on Docker, VM, etc. and all. So the 3-4 questions what popped up is, how can I do the same set of activities with Meson? How can I do with the same set of activity for my custom PMD and library? And end of the day, how can I have the right set of flags which will talk back to my end application to do the things? These were some of the things what led us to explore and come up with some of the suggestion. Over to you, Shiva.
Okay. So yeah, so with that, given that problem statement, and now we will take a look at how those problems can be addressed with Meson. And okay, this is all like what a DPDK documentation has to offer, and some of the options can easily help to solve those problems, like what we listed here to configure builds and then customize the configuration according. And similarly, if you wanted to cross build to specific targets, you can do that. Now let's take one problem at a time and see how we can do that with Meson. So the first problem, let's say if I wanted to just replace make with Meson, and if you wanted to just create a native build and install the build on a specific target directory rather than instead of having installed on the default directory, which is a /user local. And this could be required if I wanted to have multiple builds with different DPDK versions or for different targets. So I might be required to install it on a different install directory. So in which case you can configure that using this -- prefix option and specify the target installation path, and just fire make ninja install. It will the built binaries and libraries will be installed in that install path. Similarly,
Shiva, just to interrupt, there is a small request. You have that sharing tab. Can you just pull it a bit down? It is coming in between of the presentation. That tab which shows stop sharing and all. Can you just pull it a bit down? Yeah, thank you. Please continue.
Okay. So these are the other options to configure the lib directory paths or the install paths and all which can be used to customize.
So this is native build.
Yep.
What about cross build, Shiva?
Yep. So similarly, if I wanted to cross build for my specific target, which is not supported in the existing DPDK configuration. So I'm here just for example, here I'm trying to add cross build support for a specific target, which is not listed in the DPDK configuration, in which requires me to add my own cross build configuration file. And then I also did a small patch just to check if the build target matches, then accordingly just specify the build specific machine arguments accordingly. And so in crux, with minimal changes to the configuration, you can actually do a cross build how you do it with make.
So Shiva, just to recap what you were trying to share. So if I don't find my relevant settings or relevant C flags or other things, you're suggesting that we can go and add something and get it done quickly without much effort.
Exactly.
Right?
Yeah, exactly. Yeah.
Thank you.
So the second problem is that was listed, raised by like users are like, how can I selectively enable or disable some of the applications which may be required for sanity verification, and all. Like, in this example, like I wanted to just enable L2 forward, L3 forward, instead of instead of enabling all the other applications. So how I can do that? So we can do that using this configure option -t examples, and just to specify all the list of applications that you wanted to build with the comma separated value, through comma separated values. And similarly, like you can do the same thing for cross build as well. And here you need to just specify the cross build configuration file for that.
Okay, these are the certain set of things what is already there in the documentation, and with
Yeah.
which we can get the things done, except for the cross build part. But how can I solve or disable certain libraries and other things?
Yes. So currently DPDK supports some of the configurable options which can be customized or which can be configured. Say for example, if I'm trying to build DPDK for a specific target like a VM or a Docker, which does not require vendor specific or physical NIC PMDs, or like if I'm trying to build for a native bare metal environment, in which case I don't need a vhost or a pcap PMD. I can just specify that the PMDs through the driver paths, and like you can just list down all the PMDs how that you wanted to disable, and when you just with that you can actually disable those respective PMDs and PMDs. Of course, there are certain things like which is not currently exposed through the configure options, which we are going to talk in the subsequent slides.
So what you mean to say, inside the root folder of DPDK, there is meson options. These list what you can enable, disable, and all. And that is what we go and enable and disable as of today. And that is covered in the documentation.
Yes,
Now you're going to tell us and teach us how we do it for the things which are not there, but customers use it.
exactly. Yeah.
Okay?
Yep.
Yeah.
So there are a set of custom PMDs and libraries which are meant for proprietary devices and which is not part of the vanilla DPDK. In which case, customers may be adding their own PMDs and libraries on top of the vanilla DPDK. For such customers, like if they are
Correct.
trying to build, like if they are trying to make these PMDs built along with other drivers and libraries, they just need to include the add a meson.build, like how they are doing with Makefile. They need to include all the sources and the header files along with the dependencies. And similarly, like you need to just add those new PMDs in the master in the master. If it is a network device, you need to just do that in the driver/net. You need to just add it in the meson.build file, and so along with the other drivers, like the custom drivers and libraries will also be built. Similarly, like if you are adding a new library, if you are adding a custom library, if you wanted to include, likewise you need to just include that in the lib meson.build file. And then you also need to add a meson.build in the custom library. But like say, this is similar to how you're doing it with Makefile.
Okay.
So this is another case like wherein, okay, so DPDK currently exposes some of the configurable options. I wanted a case like wherein I'm having a problem with the memory allocation or memory failures. So I wanted to debug. I need to create a debug version of the malloc library. So with the current options, like I do, I like I'll not be able to enable the malloc debug without having to rebuild or with a special compilation flag or like that. How I can do that with the meson? So you can actually so the meson options currently exposes the list of options. You can just add custom options to the meson options, like malloc debug if I want to expose it, so that like dynamically you can enable or disable that debug version of the malloc library. You can just add this option in the
Okay.
meson options.txt, and you need to just modify that meson.bit configuration and add this flag, so that like when the option is selected, you can just enable the compilation flag, the debug flag accordingly. Similarly, like if you wanted to add like other options to enable or disable dynamically, you can just add those like how we have listed here.
Okay. So that solves certain settings. So how do I integrate this into my existing Makefile system or Yocto at the end of the day, or even OVS, for example?
Okay, so what DPDK documentation suggests is like, if you are using a make infrastructure, you need to just include these settings to include your C flags and the LD flags with, so that the package config can either pick the DPD pick the libraries and the header files from the package config path. And similarly, if you have the Meson infrastructure as of today, you just need to include this. You just need to include these changes into the Meson infrastructure to, so that like it will pick the libraries and the header files. So the other thing is like, with Meson, if you are having multiple targets, or if you need to just include the target specific libraries and header files. With Meson, all you have to do is identify, just point to the right package configuration file, and everything will solve on its own. So
But Shiva, here is my problem. The package config that you said, isn't that looking in the user folder or root folder and all? How do I make it point to my desired target folder?
you just need to set the PC package configuration file environment setting, so that it will pick the right package config file. So the
To my
default, yeah,
DPDK
yep,
build folder.
exactly.
Okay.
So with that, summarizing, like, so if whatever things you are actually trying to do with Makefile, you can do all those things like, with Meson. So for just to cap here, like if you wanted to create a configuration file, you just with Makefile, you just do make config and point to the right target, and then along with the install path, you can do the same thing with the Meson. You just need to call the Meson configure, and then to specify the target installation path, you need to use the minus minus prefix option, and the build configuration is created. If you wanted to edit, like, if you wanted to make changes to the configuration file with Make, you just go and edit the .config file in the target directory. So, similarly with Meson, you just need to call Meson configure and make the changes to the make the configurable changes, and accordingly, like the configuration will be modified accordingly. So in fact, with minimal changes to the configurable options and to the cross configuration files, so you're able to achieve with whatever you're doing with Make in Meson. So finally, like, if you are building the target like Make, you just need to fire ninja install just to build that. And similarly, like, if you are building your application, you have two ways of building your application with the DPDK build infrastructure. Either you just need to specify the right make file that you are trying to include, or you can just specify the DPDK include path and the library path along with the C flags and through LD flags. Similarly, like with
Okay.
Meson, you just need to point to the package configuration file, and then you can just using the package configuration file, you can actually include the libraries in the header files.
So as from the customer point of view, what we are trying to say is that, hey, get acquainted with the Meson options. Number one, there are certain parameters which are available in the Meson options.txt, which you can readily enable, disable, even set the number of NUMA and other things and all, which is very good. But for the things which you are missing out, with minimal edit, you can make it work and get the things done. Thus, your bitbake or cmakes can run a patch and invoke the meson command and ninja and put it into your desired target folder. And using the package config in the target folder, you can get the relevant C flags and LD flags and make it work. That is what we had to share. Thank you.
Thank
We
you.
can take up some queries. It looks like many of the during the presentation there were many questions. Thanks to Bruce and Natalie and others, most of the questions are answered and discussed. As some and Farouk also, as someone who has recently integrated with DPDK Meson business, it's straightforward. Great job. Okay, that's Anthony has given a comment to the DPDK community. Good job in migrating into Meson. Uh, that's all, I believe. So please ping us, feel us free, and of course, Bruce is always available. Please reach out to Bruce too. He's an expert on Meson too. Thank you all for hearing us out.